Good evening, students.
Good evening, sir.
So last class we were discussing about the strain, isothermal process, adiabatic process, and also the relation between volume strain, lateral strain, and Poisson ratio. Poisson ratio, volume strain, and lateral strain. So the relation here, first of all, recall the relation between delta V by V is equal to and delta L by L into 1 minus 2 sigma. This is a relation between the relation among volume strain, lateral strain, longitudinal strain, and here Poisson ratio. Okay. Now one problem based on this formula. One problem here already ఇక్కడ రాసిన చూడండి. ప్రాబ్లం దేనిపైన రాసిన delta V by V is equal to delta L by L into 1 minus 2 sigma. Here sigma means Poisson ratio, delta L by L longitudinal strain, delta V by V. This is here volume strain. It is called also fractional increase of the volume. Okay. First of all, see here problem. Find the fraction increase in volume. This is a delta V by V. That means here fraction increase in volume of the cylinder. Okay. Cross section, if its longitudinal strain is 1%, that means 1% means here longitudinal strain, delta L by L means longitudinal strain. అవునా కదా, దీని విలువ ఎంత మనకి ఇచ్చిన గివెన్ వాల్యూస్ హియర్ 1%. సో Poisson ratio 0.30. This is the Poisson ratio of the metal cylinder. Okay. Now find out the fractional increase of the volume. So delta V by V. We find out the delta V by V. Okay. Now first of all given values. చూడండి ఇక్కడ ఏమి ఇచ్చిండ్రో మనకి ఫైండ్ అవుట్ ద హియర్ Poisson ratio గివెన్ డేటా. ఓకే, సౌండ్ వస్తుందా? గివెన్ data here, question mark delta V by V is equal to fractional increase of the volume. Now longitudinal strain ఎంత ఇచ్చారా given values here 1%, that is equal to 1% is equal to delta L by L is equal to here 1 by 100. Delta L by L is equal to 1 by 100, that is equal to 1% of the increase of the length of the wire. Now next the Poisson ratio here, Poisson's ratio given value sigma is equal to 0.30. This is a Poisson ratio of the given wire. Now find out the fractional increase of the volume of the cylinder. Okay. First of all, the relation between trees equal delta V by V is equal to delta L by L into 1 minus 2 into sigma. Okay. This given values substituting in here. ఎక్కడ ప్రతిక్షేపించాలి మనం ఇవి చెప్పండి రైట్. ఒకటి ఈ వాల్యూస్ ఎక్కడ సబ్స్టిట్యూట్ చేయాలి? డెల్టా L V by V is equal to delta L into 1 minus 2 sigma. So this values here substituting the fractional increase of the volume by V by V is equal to delta L by L, that is equal to 1 by 100, that is equal to 0.01. It has no units and dimensions, that is also a strain. అదేంటి మనకి ఇక్కడ strain. So the value is 0.01 into 1 minus according to formula 1 minus 2 into here sigma values 0.3. Okay. Simplies 1 minus 3 2 ja 6, 0.6. 1 minus 0.6, that is equal to 0.4. Correct or not? So the fractional change in increase of volume delta V by V is equal to 0.4. This is a here fractional increase of volume of the given cylinder. This is the answer of the given question. Next problem here. A metal cylinder of length L is subjected to a uniform compressive force F. Here force here, compressive force here F, as shown in the figure. So diagram rasa in the figure. The material of the cylinder as Young's modulus Y. Young's modulus Y. Okay, and Poisson ratio here. Poisson ratio sigma. Poisson ratio here sigma. The change in volume of the cylinder is. Change in volume of the cylinder is. ఇక్కడ ఏంద్రా ఏ ఫోర్స్ అప్లికేషన్ చేస్తుందో బ్లాక్ పైన సిలిండర్ పైన compressive force. The compressive force here, given force here F. Here from the diagram, note this one first of all. Okay, first of all, cylinder A, this is a chalk piece is a cylinder. Yes or no?
Yes, sir.
Okay, now diagram. Okay, now this is a, for example, base surface. This one here surface. The cylinder placed on the this surface. The cylinder here placed on the this surface. This is a cylinder. Okay, this one here cylinder. Now the area of the cross section of the cylinder here A. Area of the cross section here A. The length of the cylinder initially L. The length enta manaki here first of all L. Okay, this is the length of the cylinder here L. Now the force subjected to the this cylinder, the compressive force here compressive force. This is a compressive force. This force acting perpendicular to the this area. Yes or no? అవునా కదా, దానికి పర్పెండిక్యులర్గా ఉంది కదా. This force here F. This force here F. Now after that the force, the cylinder is compressive. దగ్గరికి వస్తుందా లేదా? Yes or no?
Yes, sir.
So change in length here, change in length here L, change in length here L. Okay, ఈ ఫోర్స్ దీనిపైన అప్లికేషన్ ఇస్తే ఆటోమేటిక్గా ఏమవుతుందండి, కంప్రెస్ అవుతుంది. సో చేంజ్ ఇన్ లెంత్ L, ఒరిజినల్ లెంత్ ఆఫ్ ద సిలిండర్ L, ఏరియా ఆఫ్ ద క్రాస్ సెక్షన్ ఆఫ్ ద ఏరియా సిలిండర్ A. Now the Poisson ratio of the this volume sigma, the change in volume, the volume strain here given uniform force material. Okay, initial volume here, initial volume V, and after that here, after that that force here change in volume here delta V. V means initial volume, delta V means change in volume. Now this formula from equation delta V by V is equal to delta L by L into 1 minus 2 into sigma. This formula. Okay, here Young's modulus of the this cylinder, given cylinder Y. Young's modulus of the here given cylinder here Y. So Young's modulus of the this cylinder here Y. Now according to Young's modulus, Y is equal to here Y is equal to force into original length by area into change in length. Change in length. This is the Young's modulus of the this rod. So Y is equal to formula ఏమో రాశారు ఇక్కడ, Y is equal to F L by A into delta L. So here L means L by delta. This is the 1 by strain. That is equal to change in strain is equal to delta L by L. Delta L by L. That is equal to ఏమవుతుంది here. This is one step here. Okay, Young's modulus Y is equal to force into length, original length by area of the cross section into change in length. Now simplifies Y is equal to force by area into here change in length by length. Change in length by length. So change in length by length, that is equal to strain. So strain is equal to here delta L by L is equal to ఏం రాయొచ్చు దీన్ని force by area into y. ఓకే, it is correct or not? Correct అయినారా ఇది? సో delta L by L is equal to force by A into y. Here given question, change in volume of the cylinder is, we find out the change in volume of the cylinder, that is equal to here change in volume delta V is equal to question mark, delta V is equal to question mark. So this values delta L by L values, and okay, we this values here substituting, this values here substituting. Now simplifies delta L by delta V by V is equal to delta L by L y f by a y into 1 minus 2 sigma. So we want just change for volume of the cylinder, change for volume of the cylinder. So delta V is equal to f v by a y into 1 minus sigma. This is the answer of the given problem. This is the answer of a given problem. So change in volume is equal to f v by a y into 1 minus 2 sigma. Here sigma means Poisson ratio of the cylinder, v compressive force, v original volume of the cylinder, a area of the cross section of the cylinder, here y Young's modulus of the here given cylinder. This is a problem. Next one, now note this one. Clear? Problem clear అయిందా అది? Now a uniform rod of length L, the tensile forces, two tensile forces acting opposite side of the two ends of the rod, okay. Here this is a cylinder, for example, and this one here cylinder, okay. The area of the cross section, for example, A, the area of the cross section here A. The two forces, tensile forces, here tensile forces acting opposite ends of the rod, అంటే ఇక్కడ ఏం చేస్తున్నా opposite direction లో force application చేస్తున్నా, ఏం చేస్తున్నా ఇక్కడ opposite force లో, okay, this force. Here this portion, this is a PQ is a cross section of the this rod, cross section of the this rod, PQ చాలా very important right, చాలా జాగ్రత్తగా అండి. PQ is a cross section of the area of the cylinder, uniform cylinder, okay. Now this one, this force acting here, this portion ఇక్కడ ఏంటంటే ఇలా ఉంటే ఈ ఫోర్స్ ఎలా ఉంది, ఇది పర్పెండిక్యులర్, జస్ట్ ఇప్పుడు పర్పెండిక్యులర్ ఉందా, దిస్ ఏరియా, దిస్ కట్ సమ్ కటింగ్, సో దిస్ ఏరియా as making an angle, this is a plane, PQ is a plane, this one area, this is a plane, this one here plane, so this force here F force, so the plane is solved into two mutual perpendicular components, so here this one, for example, A cos theta, and this one here, for example, here A sin theta. The A sin theta parallel to the cylinder, surface of the cylinder, this A cos theta area perpendicular to the this cylinder. అర్థమైందా? ఈ రెండు కాంపోనెంట్స్ ఏం చేసిన dividing to two parts, so this is a, for example, A prime, so this one, this force perpendicular, this one here force here perpendicular, another one force here parallel to the surface of the area, అంటే ఇక్కడ మనకి రెండు ఫోర్సెస్ అప్లికేషన్ అవుతున్నాయి, F sin theta, F cos theta perpendicular to surface of the cylinder, and F sin theta parallel to the surface of the cylinder. So the F sin theta means here tangential force, F cos theta here perpendicular force. So first of all, this making an angle. So first of all, stress, two stresses here. First one, tensile stress. Tensile stress is equal to normal force. Here, normal force into area, into here area. Okay, into area. Here normal force means is equal to Fn by here An. Here Fn is equal to F cos theta and An is equal to here A cos theta. ఇక్కడ ఏం రాసిన వాల్యూస్ హియర్ Fn is equal to F cos theta, An is equal to A cos theta. These two values here substituting. Normal force by here, this is a normal area. So these two values here substituting. So tensile stress is equal to now here tensile stress is equal to normal force means F cos theta by normal, this is a wrong. Normal area is equal to A by cos theta. So here A by cos theta. So this is a tensile stress. So this simplifying after we will get F cos theta into cos. Okay na? Simplifies here F cos theta into F cos theta by here A. Cos into cos square. So simplifies here F cos square theta by A. Therefore tensile stress is equal to here force and cos square theta by area. This is a tensile stress. This one here tensile stress. When the maximum tensile stress will be cos theta is equal to here cos theta is equal to 1. Cos theta is equal to 1 here. Now the maximum stress, which stress here? Tensile stress. Cos theta is equal to 1. Cos theta is equal to here 1. Now theta is equal to cos inverse of 1, that is equal, theta is equal to 0 degrees. Clear? Cos 0 is equal to ఎంత ఉందా? ఇది రాసింది కరెక్టేనా? Correct or not? Theta is equal to cos inverse of 1. Here tensile stress is maximum, so cos theta is equal to 0. So theta is equal to cos inverse of 1, that is theta is equal to 0. So ఎప్పుడు maximum ఉంటుంది tensile stress here? Theta is equal to 0 degrees, ante both are in same direction, same direction. After shearing stress, now shearing stress means the tangential force applied to the surface of the cylinder, both are same direction. Ila ela unnadi ee force anedi tangential force application of the surface of the cylinder. Okay, now next one, shearing stress. Note this one, very important in JEE means and NEET. ఈ పాయింట్స్ డైరెక్ట్ బిట్లు అడుగుతారు, డైరెక్ట్ బిట్స్ అడుగుతారు. ఓకే, నెక్స్ట్ వన్, shear stress. Now shear stress means shear stress is equal to tangential force by area. Tangential force by area. So tangential force means F sin theta. Here tangential force is equal to F sin theta, and here area of the normal force, normal area is equal to A by cos theta. So here tangential force is equal to tangential force by a normal area. These two values here substituting. ఈ రెండు కూడా అక్కడ సబ్స్టిట్యూట్ చేయండి. అప్పుడు ఏమొస్తారా షేరింగ్ స్ట్రెస్ హియర్ షేరింగ్ స్ట్రెస్ ఇస్ ఈక్వల్ టు FT. FT means tangential force. So F sin theta. F sin theta by area. Area is equal to A by cos theta. A by cos theta. Now simplifies here. Shearing stress is equal to F cos theta into sin theta by area. Sin theta by area. Okay. So multiply this equation, multiply and divide with 2. రెండుతో గుణించి భాగించండి. రెండుతో గుణించి ఏం చేస్తున్నారా భాగించండి. అప్పుడు now sharing stress is equal to F into 2 cos theta here sin theta by 2a. Clear? Doubt? ఏం చేసారా మల్టిప్లై అండ్ డివైడ్ విత్ 2. 2 by 2 get cancel, remaining same equation. So this is equal to 2 cos theta sin theta is equal to this one sin 2 theta sin 2 theta. Okay, here shear stress is equal to F here sin 2 theta by 2a. This is a shear stress of the cylinder, given uniform cylinder. So shear stress is equal to F sin 2 theta by a. Now if the maximum tangential stress, so sin 2 theta is equal to 1 here. Now the maximum tangential stress is equal to here sin 2 theta is equal to 1. Sin 2 theta is equal to 1. So here 2 theta is equal to sin inverse of 1. Here that is equal to sin 2 theta is equal to, this is equal to 90 degrees. This one is equal to here 90. So 2 1 ja 245 ja 240. So theta is equal to 45 degrees. Theta is equal to here 45 degrees. This is a here maximum tangential stress. Maximum tangential stress is equal to here the maximum tangential or sharing stress theta is equal to 45 degrees. అంటే theta is equal to 45 degrees ఉంటప్పుడు ఏంది maximum మనకి ఏముంటుంది షేరింగ్ స్ట్రెస్. అదే విధంగా మనకి ఇక్కడ 90 degrees ఏదైనా టెన్సైల్ స్ట్రెస్ is equal to theta is equal to 0. Theta is equal to here 0. These two questions very important in JEE Mains and NEET. Two questions, direct bit 2. Okay. Next one. Note this one. Next one problem. Now a uniform rod. Just one. Listen. Two forces acting perpendicular to the are tensile forces. Two forces here, tensile forces acting two ends of the rod, two ends of the uniform rod. Find the stress, find the average stress and find the change in length. First of all, listen here. Question ఏంటినా మనకి, this is a uniform rod. This one here, example problems. This one here, example problem. This is a uniform rod. Okay. Area of the cross section here A. Area of the cross section of the rod here A. Here two forces F1 and F2 acting perpendicular to the this cross section here F1, this one here, this is a F2. Okay, the Young's modulus of this rod initial y. Young's modulus of the y. The Young's modulus of the wire here or rod here y. Length of the rod given. Initial length of the rod here L. Initial length of the rod here L. Okay. Find the change in length. Here question mark ఏంది? Find the change in the length, change in length, just to change in length. Okay, given that here how many forces here acting? Two forces. These two forces different forces. This force acting two ends of the given rod, so first of all stress, well, two ends means here one end A, another end here, for example B. One end here A, another end here B. అంటే ఇక్కడ ఈ రాడ్ పైన టూ ఎండ్స్ పైన ఫోర్సెస్ డిఫరెంట్ ఫోర్సెస్ యాక్ట్ అవుతున్నాయి. ఎన్ని ఫోర్స్ యాక్ట్ అవుతున్నాయి? డిఫరెంట్ ఫోర్స్. Here one is F1, another one is here F2. Now the initial length of the rod here L, Young's model of the rod Y, area of the cross section here A, area of the cross section here A. Now find the change in length of the rod. Okay, two force act అవుతే ఆటోమేటిక్గా ఏమవుతుంది? సాగుదల వస్తుంది కదా సరే. సో find the elongation in the rod or change in length, that is equal to question mark here delta L, question mark here delta L. Now first of all stress is equal to at here stress at A point, at A, stress at stress at A, so is equal to F1 by, for example F1 by ikkada area is A, that is equal to here F1 by 5 r square, 5 r square, 5 r square. Next stress at B point, here F2, that is equal to here F2 by A, F2 by A. For example same uniform also F2 by 5 r square, 5 r square. Now average stress of this rod, average stress on the rod, so average stress is equal to total force by 2. So here for example this stress is equal to here F1, F1 small f1, this stress here F2. Small f means stress, small f2 here stress, another end. So average stress is equal to here F1 plus F2 by just 2. So F1 F2 value substituting their formula, F1 values here formula F1 by A, F2 for small f2 is equal to F2 by A. So these two values here substituting. So average stress is equal to average stress, for example AVG is equal to F1 means capital F1 by A plus F2 is equal to F2 by A by 2. So simplies here average stress is equal to same, the denominator is a same, so F1 plus F2 by here 2A. This is only for average stress, this is only for average stress. Now the Young's modulus of the given rod, now Young's according to Young's modulus here y is equal to formula, y is equal to force by here, force means stress, force by here stress, okay, stress by area, sorry, stress by strain nothing but here delta L by just L, delta L by L. The Young's modulus is defined as the ratio between longitudinal stress to longitudinal strain. This is called as here Young's modulus. So here F0 means average force, average stress, here average stress by strain. So we want just delta L by L, we want change in strain or change in length of the given rod. So delta L by L is equal to ఏమొస్తుంది here formula average stress by here y, average stress by y. So Now find out the delta L. Delta L nothing but here delta L is equal to L into L means original length of the rod. Original length of the rod. Here average stress. Here average stress means this one here average stress. Okay, this is equation 1. Here this is the equation 2. Equation 2. Sorry, this next one other step here. Delta L is equal to L into average stress by Young's modulus. Average stress by Young's modulus. This is the equation 2. This one here equation 2. Now from equation 192. From equation 192 అంటే 1 2 ల నుండి 1 2 from equation 192. From equation 192 here from 1 and 2 delta L is equal to L into here average stress is equal to this one F1 plus F2 by 2A by Y. Now this is equal to here delta L is equal to L into F1 plus F2 by 2AY. This is the answer. This is one here. Change in length of the given rod. Change in length of the given rod. Delta L is equal to L into original length into two forces. The sum of the two forces. These forces are tensile forces. These forces are here tensile forces and 2 into A into area of the cross section of the given rod. Here Y means Young's modulus of the given rod. This is the next problem. Okay, ఇక్కడ ఏం లేదు. వాడు ఏం చేసిందంటే యూనిఫామ్ రాడ్ తీసుకున్నారు. ఏం తీసుకున్నారు? హియర్ యూనిఫామ్ రాడ్. Two forces acting on the two ends of the rods. Here these two forces opposite. These two forces here opposite forces in different forces. So now the elongation in the wire here rod L, original length L, Young's modulus Y. Now first of all stress at one end, stress at one end, stress at another end. So the average stress is equal to here given average stress is equal to F1 by A plus F2 by A by 2. That is equal to average stress is equal to F1 plus F2 by 2A. Now change in length is equal to L into F1 plus F2 by 2AY. Okay, note this one. Next problem. Headwood machine. Please see. Question here. Two blocks of masses M and 2M. These two blocks connected with the string or wire overcome the frictionless pulley. Now find the here the stress of the wire, stress on the wire here F0. Find the elongation of the wire or stress. Question chepra. So here two blocks are masses here masses M and 2M. These two are connected through a wire. Connected through A by breaking stress here of breaking stress passing okay. Yeah, this is the here F means sorry. Here F means this is the breaking stress. F0 means here breaking stress. Passing over the here passing over the frictionless pulley. Frictionless here pulley. Next, the Young's modulus of the maximum radius of wire to be of wire to be
used so that
wire to be
used
uses
so that the wire may not break is
the wire
may not break is
made
may not break
may not break is okay, break is. Now according to this formula, find out the radius of the wire. First of all, two blocks overcome the frictionless pulley. The breaking stress here F naught. For example, the Young's modulus of the wire here y, and the radius of the wire here r. Find the radius of the break keys. Okay, question mark here. Find radius, very important, radius of wire. Okay, that is equal to here r is equal to. So first of all, diagram. This one support, rigid support, this is a rigid support, this one here frictionless pulley, Now two blocks connected with the wire, here one block here 2m, another block here just m. So this block moving downwards here, this block here moving upwards. The tension in the stress string here T. Here tension nothing but force. And this block moving downwards, this block moving upward direction. This pulley is a frictionless pulley. The area of the cross section of this wire A. This wire here A. Okay, that is equal to phi r square. Now find the here stress, breaking stress. Here breaking stress is equal to F naught, area of the wire, wire r. Okay, area of the. Now according to this formula, first of all find out the tension in the string. First time call tension in the string. After that stress. After that Young's modulus of the wire. Now note this first of all question. Okay, now first of all Young's modulus y, area of the cross section A, length of the wire we don't know, and breaking stress F naught. Find out the radius of the wire. So first of all, tension in the block, blocks. Here T is equal to here 2m1 m2 g by here m1 plus m2. This is a tension in the block. Two blocks here connected overcome the frictionless pulley. So according to tension formula, T is equal to 2m1 m2 by m1 plus m2. This tension nothing but here force. So stress is equal to, first of all, next stress here breaking stress is equal to here tensional force by area. This is a T, this one here T, A is a tension. So area is equal to tension by stress. Here tension by stress, breaking stress, Now that is equal to A means phi r square, area of the cross section area of the wire. So A is equal to area of the wire. So that is equal to here phi r square is equal to tension by here F naught. So area is equal to radius of the given wire is equal to here T by phi F naught. T by phi F naught. But here T values here substituting, this values here substituting. So radius of that wire, given wire, r is equal to under root, this is the under root of here T values 2 m1 m2 g, acceleration due to gravity g means here into here m1 plus m2 by phi into f naught into phi into here f naught. Now here m1 is equal to just m and m2 is equal to 2m. This is a m1 is equal to this one here m2. These two values here substituting, after we will get here the radius of the given wire. So simplies r is equal to 2 into m into here 2 m by g m plus 2m 3m into phi f naught phi f. So once here phi mm get cancelled, once get cancelled under root. So 2 into 2 4 mg into 3 phi f naught. Here f naught means breaking stress. So simplies here r is equal to 4 mg by 3 phi f naught. This is here the radius of the given wire, this one answer. Okay,
Okay, sir.
thank you.